So let me tell you. So I joined this company about a couple of years ago after working at Intel, and it was a very interesting challenge that I can talk about today whenever my computer decides to show something as a spinning wheel. So the challenge was the following: is that there are a lot of cities in the world, and that more and more people live in cities, and cities are growing. And there's an interesting statistics that show that the number of issues grow linearly, and actually sometimes faster than linearly with the size of the cities. And so there's a lot of research now, and I don't know if you heard about, there's a term called smart cities that, that was coined by companies like IBM, and they're trying to use technology to get different parts of the city connected each other to better monitor, like a dashboard, and give access to everybody that works in the city, or maybe also the public, to get access to the different pieces of the information, and try together to better optimize or make better decisions on how, I don't know, this one, I guess. So that company is called ScreenPoint, and we're trying to do something called smart cities. The main idea would be to see if 3D graphics would help doing that. So, you can imagine in a city they have a lot of documents printed, or Word documents, or Excel spreadsheet, and sometimes website, and a lot of dynamic information. And the idea would be to, in that model, to provide a client-server model where you can collect all the data and then map it to the 2D and 3D model, and display the 3D model itself. But now, not only as a visualization, but being able to go from the 3D model down to using it as if it was a web page. When you click on something, you actually go back down and get all the data, information, and so navigation and dynamic update and so forth. So what we've seen from Navtech is essential. You first have to start with a model of the city that could be used by, in the case of Navtech, like for navigation mainly, but we can use that model thanks to the fact that it's in COLLADA. It's not only for visualization, and all the data is there. Yeah, it's big, it's huge, so I can't visualize it directly, but well, then the fact that it has everything we need makes it possible to use data for many different usage. And one of the use that I look at is the use for cities that could be used for monitoring things like quality, energy consumption, green building, waste, recycling, transportation, and you name it. There's so many things that should be optimized in cities in the future, so we live in a better world, and we can better anticipate things, do simulation, understand what decisions made by everybody will impact the city itself. So we developed this software that is composed of 3 different layers, actually, that map with this cloud model. So first, the first layer is to get the data that comes in very different shape into something that we can process. So we've seen that with Navtech tools, for example, but there are other providers, and there are many other ways to do that, but we do use a lot of that system. The second layer is the database itself. So all those layers are invisible, but it's very important to have a cloud system that you can connect to. And that cloud system is going to provide you access with 2 things. First, it provides you with the user interface, so the user can navigate and do things. And the second thing provides you with all the 3D models. And those 2 streams of data now goes into the client, and where the client is the visible part of it. And the client is actually composed of 2 parts. One is an HTML web browser that can navigate the HTML and the JavaScript. And the second part is the 3D engine that will display the database that comes from the engine. So now you can, it's called 5D because you can obviously navigate in 3D. When you click on something, it has a link and it actually refers to a lot of other data. That's the fourth dimension. And the fifth dimension is a time, and that's really important because you can actually navigate underneath the city and so forth. I mean, that the 3D aspect is really important. The map doesn't provide enough information to understand what's going on in the city. The documentation is important. Where if I click on something, I can see where it is at and what was supposed to happen and who's responsible for it. The time aspect is also important because if I look at a city at a date and I look and I move my cursor and I go what's going to happen in the future, I have all that in the database. And it's very important that I know when, where, and what, and that's 5D. And that's so basically what we build is an extension of the web where we not only look at 2D pages and links, but everything becomes a link that has time, that has 3D location, and of course points to data like links on the web. So we'll attempt to, a lot of things you could do with that. You could imagine a dashboard and then you can look at video cameras that are in the city. Just that, just being able to click on the 3D city and being able to know which cameras are looking at what you're interested into and report the incident. Those are things that would be very useful. Also, being able to have your city on a mobile device where that feature is not very relevant, but you could be in the city and you would like to take notes. And I mean, as a worker, you have a lot of ways to interact with the city itself. So that's, I keep that short because I'm going to attempt to, and I don't know if it's going to work, but navigate database while it's streaming, and that's the idea of the system. It is paging now, okay. So we need to optimize that loading mechanism because it's paging data that's not next to the camera, so we don't even know what's visible or not. So that should have started that a little bit earlier. So it does page. So the 3D engine is actually paging data on its own from the database. Those are the different tiles you can see. There you go. Some of the tiles become visible, and it's going to keep paging and paging and paging those gigabyte of data. It should not page things that are not necessarily useful. And then while it's paging, you can navigate the database. The thing here, and that's what's very important for us, is that every single one of those buildings or roads or objects that are in the database have a ID. So if I click on that thing, there's a couple of things that happen. I'd like to show it. Damn it. Okay, video driver, I'm not happy. Okay, I know what's going on. So, anyway, I apologize for that. The thing is, every one of those buildings, when I click on them, I can recognize them, and I know that the entity, and I know the ID of that entity, and I can go then with that number, fetch down onto the system to a database and finding the information and what that are attached to that ID. In COLLADA, you have this notion of ID of an object and a name of an object. So we use the ID to reference the object, and the name actually we use that to give information that that can be shared between different 3D objects. So if you have, it looks like the resizing the window crashed my driver. So when you have a building that's composed of many different parts, if you click on it, you don't want to necessarily select the different parts separate. So what we do is we look if there's a name, and if that name is also into all the objects, then we're going to select all the objects that have the same name, whether or not they're in the same tile. So that way, it doesn't matter if the building has been split in half by a tile, or if it's in whatever tile it is, or if it's actually a set of buildings that compose the object that we are interested in attaching data to. We can find that object in database. So, like I said, every one of those objects can be oh, it's interesting, this one is removing the object. But you got the idea. You can click on the object and something happens. Either it changed color or you know, now it decided to. That's cool. I can make a game with that. Like, using destroying things. Oh, that's cool. Anyway, that's a fun thing about iPad software, but well, I'm pretty happy with that because this database is like, you know, there's, I don't know, 30,000 buildings, and I don't know, but the size
that one was 120 square kilometers.
It's just humongous. I don't even, I mean, I didn't even go to, I mean, there's no way I can go and check all those buildings and see if they are the right place or whatever, you know, it's just, I don't know. And that's the type of data we need to deal with, and every one of the customers we're going to serve are going to be interested in one particular building somewhere at a very specific location, and you know, we've got to make sure it's there, and when you click on it, there you go, it's changed color now, you can actually have the ID and go find information on the web. So it could be anything such as finding the model on Google Map, or querying who's the owner and how much consumption you have, depending on the user. So the idea is that the whole user interface is on JavaScript, so it's kind of easy to then create your own kind of web page on top of that 3D model. All right, so I used enough time, and we're going to say stuff now with the COLLADA performance test. Thank you.